Hi, Billy Mays here for The Mole. Today, we're going to be taking a look at the empirical and molecular formulas. So let's take a look. Empirical formula is defined as the smallest whole number ratio of atoms in a compound. Empirically, it tells us what the smallest whole number ratio is from one element to the others. For example, we take the compound C2H6. That's its true formula, what it's actually made of. It has 2 carbons for every 6 hydrogens. Well, to find the empirical formula, we reduce that 2:6 ratio, and you get CH3. Now that's the empirical formula, a 1:3 ratio, reduced from 2:6. So how do you find empirical formulas? Well, step 1, you find the mass or percent of each element. Now if they give you a percent, then you just assume you have 100 grams and change the percent to grams. And if you have grams, or once you convert to grams, you will need to take step 2 and convert to moles. To do that, you could use the molar mass from the periodic table. Once you have moles, you look at your numbers, find the smallest one, and divide all those moles by that smallest number. This will tell you the subscripts for each individual element. And finally, you may have to multiply your subscripts by 2, 3, or 4 when necessary. So let's do an example. Find the empirical formula for a sample that's made up 25.9% of nitrogen and 74.1% oxygen. Well, we're going to assume when finding the value for nitrogen and oxygen that we have 100 grams of this sample. So if 25.9% of that would be 25.9 grams of nitrogen. Now we want to convert that, according to step 2, into moles. And to do that, we need the molar mass of nitrogen from the periodic table. We can see that for every 1 mole of nitrogen, you have 14.01 grams. Lining up the grams unit just right helps us reduce the grams and gives us moles of nitrogen. 25.9 times 1 divided by 14.01, and you get 1.85 moles of nitrogen in this compound. Now oxygen makes up 74.1 grams of the compound. And using the molar mass from the periodic table, we know for every 1 mole of oxygen, you have 16.00 grams. Lining up the units just right reduces the units of grams, and we're left with the unit of oxygen in moles. 74.1 times 1 divided by 16.00, and you have 4.63 moles of oxygen. So, step 3 says to look for the smaller number. Well, that would be your 1.85. So we take both of these numbers and divide them by 1.85. Now when we do that, you're always going to have one of them with an answer of 1 because it's divided by itself. In this case, that's the nitrogen. 4.63 divided by 1.85 gives you approximately 2.5. So what we see here is for every 1 atom of nitrogen, we have 2.5 atoms of oxygen. Well, of course you can't have half an atom, so we're going to have to use step 4 and either double, triple, or quadruple this number to make it a nice, even whole number. Well, 2.5 can be doubled, and that will make it a whole number subscript. So the 1 to 2.5 ratio can be doubled to a 2 to 5 ratio, giving us the empirical formula of N2O5 once we've multiplied it by 2. And that's how you find empirical formula, the smallest whole number ratio of elements in a compound. Now looking at molecular formula, we see that it's defined as the true formula. It's the actual number of atoms in a compound. We have an empirical formula of CH3. Doesn't mean it's made up of only one carbon and 3 hydrogens, just that the smallest ratio of carbon to hydrogen is 1 to 3. Well, the empirical formula, the true actual formula, might be larger. In this case, it could be C2H6. It can actually be made up of 2 carbons and 6 hydrogens in that molecule. But reduced, the empirical formula would look a little different. So don't confuse these terms. Molecular formula is the true formula, what it's actually made of. So to find molecular formula, you first need to know empirical formula. That will likely be given to you. So you could take that empirical formula and use the periodic table and find the empirical formula mass. Now, you want to take the molecular mass that will be given to you and divide it by the empirical formula mass. And this will tell you the ratio of how much bigger the molecular mass is than the empirical mass. And this will give you an answer we'll call N. This is the ratio of how much larger the molecular formula is than the reduced formula. You take that N and you could multiply it by your original empirical formula. And that will change the subscripts in your compound. Let's go ahead and try an example. The empirical formula for ethylene is CH2. Find the molecular formula if the molecular mass is 28.1 grams per mole. So I have this table here just to help us organize what we have about each. Well, we're given the empirical formula as CH2. We're told the molecular mass is 28.1 grams per mole. So here's how I want you to think of it. You have your molecular formula, the true formula, and the empirical formula, the small reduced formula. Well, think of it as your mama formula, the molecular formula, and the reduced baby formula. That's your empirical. So we know the baby formula is CH2. Well, let's find the baby formula's mass. We can do that by looking at the periodic table and adding 1 carbon to 2 hydrogens. And we see it has a mass of 14.03 grams per mole. Now, how does that baby mass compare to the mama mass? Well, 28 grams for the mama mass, the molecular formula, 14 grams for the empirical formula. Well, you can see, we can do some math and see clearly that it's about 2 times greater. The mama molecular formula is 2 times greater than the baby empirical formula by mass. That means that the formula must be 2 times greater. So if the empirical formula is CH2, we can multiply that by 2 and we get the true molecular formula, that mama formula, as C2H4, multiplying our 1 to 2 ratio by 2 and getting a 2 to 4 ratio. And now we have molecular formula. So use the mole, order it now, and converting and finding empirical and molecular formulas will be an ease. I guarantee it. Thanks for watching. Any questions, be sure to tune into other videos or go back and rewatch any of these videos. See you soon.